All right. Thank you, everybody, for coming to this talk. I know I've interrupted your coffee and donuts, so I appreciate you being here. So the name of this talk is PEP 740 and PyPI, Bootstrapping Provenance for the Python ecosystem. And my name is William, and I work at Trail of Bits. Like I said, I work at Trail of Bits. I'm the open source group engineering director there. I'm a long-term open source contributor to a large variety of things. But at Trail of Bits, I mostly work on Python packaging and packaging more generally, security problems, as well as some cryptography stuff. A little bit about Trail of Bits itself. We're 130 person approximately, cybersecurity engineering and auditing consultancy. We have a number of different specialties, but people mostly know us for our audits, as well as for our program analysis and open source work. Happy to talk about those things after the talk if anybody has questions about it. Before I get into the talk itself, I was asked to plug SigStoreCon next month. There's going to be an entire conference dedicated to topics directly within SigStore as well as adjacent areas of sort of supply chain interest. So SigStore, obviously, tough implementations, SBOMs, and all kinds of other sort of supply chain adjacent technologies. It'll be co-located with KubeCon in Salt Lake City, and it's on November 12th. And that QR takes you there if you want to scan it. And then if you take nothing else from this talk, I think this slide will sort of cap everything off. What I want, so again, you can ignore the rest of this talk if you only follow this slide. PyPI has had a strong notion of source identity, meaning the place that a package comes from, such as a GitHub repository, via this thing that we call trusted publishing since 2023. It's widely successful because it was a usability win for Python developers. We didn't require Python developers to do anything new. They had to actually strictly delete things within the repository to configure trusted publishing. From there, starting this year, we were able to bootstrap signed provenance on top of trusted publishing's identity primitives in the form of SigStore bundles containing salsa attestations. And critically, we can do this without actually changing anything about the trusted publishing workflow itself. All we have to do is flip a default within the workflow, and users will begin signing their packages. And in fact, we've already done this. It's live, it's public, and you can use it today. It's not the default yet, but you can enable it within your workflow. And so that right-hand side picture is the old status quo, and the new status quo is you delete your username and password, and you enable attestations. And with trusted publishing, you will get signed provenance for your packages automatically. So like I said, if you ignore the rest of this talk, if you fall asleep or whatever, I don't blame you. That is all you need to really know. With that in mind, I'll do an agenda. For people who aren't familiar, I'll do a quick background on PyPI, Python packaging, and Python packaging community. I'll talk about how sort of we think about systemically securing Python packaging, going back to what I was saying before about treating security first and foremost as a usability problem. I'll do a quick intro to trusted publishing, this technology that we built Provenance on top of, how we went from trusted publishing to Provenance via PEP 740, this standard, as well as SigStore. Talk about how we tied it all together, and then what we see as next for the Python ecosystem. So again, I'll start with some background on Python and PyPI itself. So PyPI is the Python package index. It's pronounced PyPI, not PyPI or anything else. It's the thing behind pip install by default. So I think pretty much everybody in this room has probably run pip install at least once. When you run it, you are fetching from PyPI. It has about 860,000 users, close to 600,000 projects, a little bit over 6 million releases, and then 12.2 million files within those releases. So those are source distributions, binary distributions, et cetera. And this translates to a huge amount of traffic pulled from the index every single day. There's about 51 billion downloads per month, as well as about 2 terabytes of traffic every single day. And that's after local caches within large ecosystems and companies, which many of them run their own caches and private indices. However, it's also somewhat inflated by some that don't do that. So for example, GitHub Actions doesn't cache natively at their network layer PyPI traffic. So we have a large amount of traffic that is just duplicated from GitHub Actions. More broadly, I want to sort of also skim over the Python packaging ecosystem and community. PyPI is just one tiny piece of this larger Python packaging constellation. And I think an important thing to realize here is that there is sort of, apart from PyPI being sort of the quote-unquote official index, there's very little that's official in the Python packaging ecosystem. PIP is vendored into CPython itself, but apart from that, there's this constellation of standards rather than edict-driven tools. So things like poetry, UV, setup tools, hatch, flit, poetry, said poetry twice, twine, et cetera. These are all driven by standards that dictate how they interact with each other, not via the Python leadership saying this is the blessed tool for this purpose. And this is this becomes an important part of the story later on. It explains why so much of what we have to do is standards-driven rather than just saying, today we're doing provenance on the package index and everybody has to verify it. It's not top-down. And this also sort of reflects a larger truth about the Python community, which is that it's massive and diverse. It has sort of every possible combination of experience, background, et cetera, which in turn makes it hard to establish a common denominator for anything, much less security practices, because you have people who are experienced lifelong Python developers in the same room or using the same packaging tools as people who are data analysts who don't know how to write Python, they only know how to consume it within a notebook. And the way that I like to think about this is that Python more closely resembles a country or coordination between countries than it resembles a normal language ecosystem. And this informs how I at least think about doing security efforts within the Python ecosystem. So let's talk about systematically securing that big complicated thing. In this context, diversity is both Python's extreme strength. It's what's made it the most popular language in the world by some metrics, but it's also a challenge to those systematic security changes. One thing that happens is that a lack of systematic planning becomes self-fulfilling because any sort of systematic change that you want to make has to accommodate all of those little things that have grown naturally over the years. And so your systematic change is really just one new standard over the 15 existing things that people do. It can also be dangerous to the thing that makes Python so strong as a community. When we add onerous requirements to things in the name of security, we scare away those newcomers and those junior developers, those people who aren't actually Python developers but rely on Python. And those people keep the community healthy by bringing in their experience, their use of the tools, their eyeballs on the open source community. Which brings me to my sort of like motivating thought here. To make systematic progress on packaging security, and especially within the Python ecosystem, we need to treat security first and foremost as a usability problem. And this comes down to sort of two core demographics within that country of Python users. There's this enthusiast demographic who are 1% to 5% who will do pretty much anything we ask them to do security-wise. They believe pretty strongly in Python as like a future as an ecosystem. And these people thankfully maintain many of the top packages within the ecosystem. The bad news is that they are still an overall tiny percentage of all maintainers. So even if proportionally they represent 70% of all package downloads, they only represent 0.001% of all packages. And that skews, that skew results in interesting security decisions we make. And then there's everybody else, which is the 95 to 99% who only care about the reliability of their workflow. Those are people who get mad when pip install fails. And so pip install must never fail for them. And more importantly, pip install must never change. There can be no difference between runs. They expect pip install to work forever. However, there is a sort of a silver lining to this, which is sometimes we can make them change if the change is strictly easier than the old way of doing things. And a good example of this is pip itself. Pip replaced a much older tool called easy install, which despite its name was not actually all that easy to use for many people. And so when pip came around, migration from easy install to pip was actually, it took a very long time because Python is gigantic, but it wasn't as hard of a lift as it could have been if the tool was more complicated or harder to use. So that's the silver lining with that larger demographic. So then the big problem. Everything that I think probably everybody in the room probably knows some variant of this, but code signing is the exact opposite of this usability desiderata. There is no real good usability story for traditional code signing solutions. On the publisher side, the people who are releasing these packages and signing them, the publishers, who are often unpaid maintainers, must generate and keep secure long-term signing keys. I don't think this comes as a surprise to anybody, but almost nobody does this correctly. We have pretty good empirical evidence over 30 years that maintainers either lose or forget to secure or fail to secure or generate weak PGP keys or similar. On the index side, PyPI must accept those signatures generated by publishers and keep them around and serve them alongside their uploaded files. This results in sort of a contradiction. If the index validates signatures, it also needs to maintain a key directory. Maintaining a key directory is operationally expensive, it's complicated, requires parsing PGP packets. Nobody really wants to do that. And if not, users, which we saw with PyPI before we disabled PGP uploads, users will simply upload random garbage in the PGP signature slot. They will upload things that are vaguely shaped like an ASCII armored signature packet, but they'll just be nonsense. And then PyPI will serve that, and then garbage in, garbage out. Users don't ever verify anything. And then more fundamentally from both of these, it's impossible to, fundamentally, it's impossible to default consumers into verifying these things. Even when the packager, which, even if the packager goes above and beyond and generates a secure key, they keep it securely, they do all the proper verification work, it's impossible to actually get downstream consumers by default to update key rings, perform verifications, and actually verify these signatures. There's just too much operational complexity there. And even more fundamentally than that, the user trusts PyPI. They don't necessarily know which identity behind the signing they should trust. And if they trust PyPI to deliver that identity without any other sort of backstop, it's really no better than integrity checking. So any approach to digital signatures on PyPI, any future approach, has to avoid all of these problems. And I'll talk about how we try to avoid these problems, starting with trusted publishing. So quick background. Since 2019, PyPI has used API tokens for upload authentication. Before that, you could upload with a username and password pair, which, again, I think goes without saying is not great from a security perspective. But since then, we use API tokens. API tokens are created manually and can be scoped down to individual projects, one or more projects, which is great because it means you can reduce your credentials down to the minimum scope they need. However, this results in kind of a weird chicken and egg problem for PyPI, where you create a project, or rather, you want to upload a project for the first time. So you have to first create an API token, but you want that API token to be scoped correctly. So you first create a user-level scoped API token. You publish the project, or create the user-level scope token, put it on GitHub, publish the project, delete the user API scope token, create a new project scope token, put that on GitHub, upload the project again, and now you have a fully correctly scoped one with 6 or 7 manual fallible steps in between. And those manual and fallible steps mean that users typically forget or neglect to make the new scope token, eliminating the entire point of building this scoped feature. Users will just use user scope tokens everywhere. So the way I frame this is API tokens are good. They're better than a permanent, non-unique password credential used everywhere, but we can do better than that even still. And our key goals, which I sort of alluded to, are misuse resistance. We want tokens to be self-scoping. They should automatically scope themselves down to the minimum needed permissions, and then minimally scoped as a sort of corollary to that, which means that users can't accidentally scope them user-wide, giving them access to all their projects at once. They should also be compromise resistant. They should be self-expiring, and they should be self-expiring, which prevents a user from hoarding credentials and then using them at an opportune date arbitrarily in the future. And then finally, more sort of vaguely, they should be fatigue resistant. They should require as few context switches as possible. And those context switches are the things I said before around going to PyPI, creating an API token, putting that API token on your CI/CD provider, publishing, deleting, creating a new one, publishing, deleting. We want to reduce those context switches because those are fatigue, and fatigue produces user error. Trusted publishing is our solution to all of the above. The basic idea behind it should be familiar to people who know about OpenID Connect. The basic idea is that we're going to use OpenID Connect to authenticate to PyPI. The good news here is that CI/CD providers like GitHub and GitLab allow workflows to generate OpenID Connect credentials. These credentials are publicly verifiable. You can use public key cryptography with a public key that's from the service itself to verify each jot. And they're strongly bound to the identity of the workflow, which in this case is something like owner repo workflow.yaml. And that tells you with a degree of pretty strong cryptographic proof that in fact this credential was produced by this workflow as tested by the service that runs that workflow. And these have various other nice security properties. They're by themselves short-lived and scoped to specific audiences, meaning that if we issue an OpenID Connect credential for PyPI and we give it the audience PyPI, in theory, no other service will accept that audience. In practice, JOTs are kind of a mess, so we do other things, but that is the theory behind them. The way we build off of OpenID Connect is we allow users to configure a trust relationship, is what we call the trusted publisher, between an OpenID Connect provider, such as GitHub, and their PyPI project. A cool thing about this trust relationship is that it's fundamentally public information. It's just the name of the repo and the workflow, or the equivalent for each publisher, which means that even if a user leaks this somehow, which we leak it ourselves in logs, it's all public information. It's the same as saying the project comes from this repo, which is already in the project's metadata on PyPI. And then during publishing, during the actual upload step, the CI/CD workflow will create a OIDC credential, zip it over to PyPI. PyPI will verify that credential, create an API token scope down to that credential's matching projects, send it back over to the workflow, and the workflow will then perform the upload with that temporary scope down credential. Again, the cool thing about this is that it looks identical to a normal PyPI API token. So this entire shape of flow fits into every pre-existing upload workflow for PyPI. In fact, we didn't have to make a single change to any of the PyPI uploading APIs or clients when we rolled out this feature, which was a pretty nice boon because, again, this is all devolved. We don't control those projects. Those projects are maintained by their own maintainers. I'll kind of gloss over this. This is sort of a high-level bird's-eye view of what's happening. Again, we start with like, user says to PyPI, I trust release.yaml on github.com/foobar to publish for project spam. PyPI says, okay, that's the relationship I trust. The user then triggers a release on GitHub Actions or similar for a version of spam, version 1.2.3. GitHub has a workflow identity. It issues an OpenID Connect credential for that workflow identity, sends that credential over to PyPI. PyPI verifies it and says it matches project spam, issues a temporary API token for spam, sends that back over to GitHub, and then GitHub does Twine upload to upload using that API token. And the good news is that this was a success. We rolled this out in early 2023, and adoption has been extremely rapid. And I attribute that rapid adoption to the fact that it makes users' lives easier. Fundamentally, what we did was we focused first on the usability problem of publishing to PyPI, and then found a way to fit the security advantages of trusted publishing into that usability scope. Yeah, or another way to frame that would be a successful alignment of our security goals around misuse resistance and self-expiry with user incentives around laziness and editing their GitHub and PyPI settings as little as possible. And on the right-hand side here are some stats from last week. So as of last week, about 400,000 files have been published to PyPI with trusted publishing. 18,000 individual projects have configured trusted publishing, and of those, 14,000 have published in the last year with their configured publisher. And this is a tiny percentage of the overall number of projects on PyPI, but the good news is that because PyPI has this huge tail of inactive projects, this disproportionately represents top and popular packages that are actively maintained on the index. So while we're not covering the long tail, we're covering the small end, which is the disproportionate number of downloads on the index, and I think that's pretty important. Okay, this is all on the publishing side. Now I want to talk about the actual topic of this talk, which is provenance. So I want to talk how we go from trusted publishing to provenance. So as a quick recap, previous attempts at digital signatures on PyPI failed because they didn't prioritize usability and default adoption. We didn't prioritize the ability of signers to upload signatures by default. But trusted publishing gives us a new route forwards, thanks to its construction on top of OpenID Connect. Because OpenID Connect credentials are proofs of identity, and trusted publishing effectively binds a PyPI project identity to an external machine identity, like a GitHub repo, we now have a cryptographic proof of linkage between a PyPI project and its source repo. And this may sound like something. It sounds like SigStore. And in fact, it's the exact same primitive that SigStore uses under the hood, but for authentication instead of signing. So we'll see how we took that same primitive, transposed it onto the SigStore model, and got the two to work together. It should make sense. Trusted publishing and SigStore are sort of peanut butter and jelly when it comes to the same primitives they use. They both use OpenID Connect credentials under the hood, which means that existing publishing workflows, which already have permission to obtain an OpenID Connect credential, can also automatically obtain an appropriate credential for full CO signing certificates from SigStore. And this can be made the transparent default because, like I said, we already have that permission. So all we have to do is request yet another Connect credential with a different audience, this one for SigStore, and perform the equivalent SigStore signing flow. And similarly, trusted publishing identity, that public configuration that we say is trust to publish to PyPI, closely maps to provenance identity, the thing that is the putative source of a package from GitHub or GitLab or any other CI/CD provider. And that right-hand side set of photos shows this. The top is a trusted publisher configuration on PyPI, and the bottom is a snippet of claims from a SigStore full CO certificate. And you can see the two closely map. I've snipped out like the workflow, but it's in there as well. So to get these two to sort of play nicely together in the context of PyPI, like I said, PyPI and Python packaging more generally is sort of standards driven, so we needed to write a standard. And the name of that standard is the very memorable PEP 740. All it does is align pretty much SigStore with Python packaging. It specifies a series of index changes as well as object format layouts that make uploading the equivalent of SigStore bundles to the Python package index possible, as well as serving those bundles. So specifically, it specifies these things that we call attestation objects, which are basically SigStore bundles. They're slightly mangled, but they're isomorphic to SigStore bundles. And those contain a signature over a DISI bundle, which contains the distribution name and digest. And the screenshot below shows this. It shows, for example, there's a project named ABI3 info, that's its version number, that's its digest, and that's what we sign over in the form of a DISI bundle. And then we have this larger thing called a provenance object. And the provenance object contains one or more attestation objects mapped up or wrapped up with their expected trusted publishing identities. So this gives you expected identity and then attestations that claim to be from that identity. And then that gives you the bootstrap for verifying these things. And then finally, changes to the HTML and JSON indices, if you know Python PEPs, PEP 503 and PEP 691, to serve up these objects via the APIs. Then that sort of brings us to the present day. We wrote PEP 740 in about, I want to say it was like January of this year, and we've been implemented ever since. And the good news is that the overwhelming majority of the work on the Python packaging index side of things is complete. So on the uploader side, we've implemented trusted publishing, or rather PEP 740 support inside of GitHub Action PyPI publish, which is the default GitHub Action workflow for publishing to PyPI from GitHub Actions. It's not the default yet, but if you enable attestations true, like I showed in the sort of original spoiler slide, you will opt into it without having to change anything else about your publishing workflow. However, in the near future, I'm going to flip that default, and it'll become the default for everybody using trusted publishing via GitHub Action PyPI publish. And then we'll look into a similar default for GitLab and other publishers. On the index side, I actually had to update this slide yesterday because it was almost complete as of Monday, but as of Monday, we merged the last index changes. So as of today, live on PyPI, if you hit the simple index or the JSON API index, you can retrieve provenance objects that are created via PEP 740. And then there's a last piece to that, which is that while these things are served in the index APIs, they're not served in the web UI itself. So when you go to pypi.org/p/project name, you don't have a little badge or anything that says provenance yet, which we all know users, what they really do when they want to verify, they just look for the little green badge. We're working on that. That'll be pretty soon. And then finally, there's an ecosystem-wide change. This is the thing that we can enable currently, but we haven't flipped the default on yet. So once the uploader default is switched, we expect similar volumes to what we see for trusted publishing because the overwhelming majority of trusted publishers are GitHub trusted publishers, and the overwhelming majority of those use GitHub Action PyPI publish. So we expect to see roughly over the next year about 400,000 attested uploads, all without users having to lift a single finger or do a single thing besides continue to use trusted publishing, which they've already adopted because it's easier to use than API keys. That's the key thing. Okay, that's where we were. Let's talk about what's next. There's an elephant in the room, which is that despite all this, there is an incredibly important thing that's missing, the most important component of any digital attestation or digital signature scheme. It's verification. I haven't talked at all about how clients are going to verify these attestations. And the reason I haven't talked about it is because, well, actually, let me back up for a second. I want to hammer home on this. We've done a lot of work on PEP 740. I'm happy with what we've done. I'm happy with how we've bootstrapped it on top of trusted publishing. But all of this work is going to be useless unless we also get clients to verify these attestations. It's going to be the exact same situation as with PGP, where people upload stuff, and the index is going to verify it now, which is great. But if nobody ever downloads it, it does not matter. It's simply there. Nobody checks. Nobody cares. It's a win in terms of transparency in the sense that because Sigstore is built around these transparency logs for both certificates and artifacts, you can now audit and do sort of like post-compromise triage. But this doesn't affect the average user who's doing pip install. And as an ecosystem, we can and should expect more than just transparency. We want actual verification in a timely manner, not just post-hoc triage. That, in turn, means that pip, UV, et cetera, need to support PEP 740, and ideally by default. And this is the problem, is that going back to what I was saying about sort of the devolved nature of Python packaging, this is going to be an incremental process, and it's going to be a drawn-out one. There are pretty large, both standards and also operational constraints on the various installers that prevent them from enabling this by default. One big one for pip in particular is that because pip is vendored into CPython and has to run wherever CPython runs, pip is entirely pure Python, which means it can't depend on any sort of cryptography components that are native code. And surprise, surprise, the Sigstore client is mostly written with Python cryptography, PyPI cryptography, which is mostly written in Rust. So we have an issue there, which is that by default, pip cannot currently enable without some kind of external plugin system, which is what we're currently working on. I just said that. So this is a current challenge. We have sort of technical approaches that we have in mind for fixing this, but it is something that's kind of fundamental to how Python packaging works. Because it's all devolved and because we can't say, today you will depend on a Rust component, or today you'll depend on any native component. We have to work on sort of creative hacks around this problem. And yeah, this is what I said. So our current workaround for this, we are developing a plugin system for pip that can then inject Sigstore Python during installation. So the idea is that you would have a bootstrapping step where you do pip install, pip plugin verify. And pip plugin verify would then inject into your install setup. And this is not good. This is not a great way to do things because now you have a trusted bootstrapping step which is not itself verified. And if anybody can compromise that bootstrapping step, you're back to ground zero. But this is the constraint we're currently working with. Things are not as constrained on the UV side because they're already a pure Rust binary, but there are separate constraints there that I'm happy to talk about after this talk. There's some other bits that are sort of future things that we're thinking about in terms of extending PEP 740 as well as the ecosystem's adoption of it. PEP 740 currently specifies two different kinds of attestations. We support these things that we call publish attestations, which are essentially just, I am the GitHub or GitLab, et cetera, workflow, and here is my package. Here is my identity for that package. Essentially the same thing as a trusted publisher. But we also support salsa provenance, so you can upload an entire salsa build statement as part of your payload, and PyPI will persist that. However, these aren't the end of all useful things that you can attest to. There are all kinds of other useful attestations, including third-party attestations. We might want to allow third parties that are trusted to say, I have reviewed this code, and here's my signed attestation that I've reviewed the code. PEP 740 has space for these, but it needs to be still sort of designed out and fleshed out. A current sort of constraint in how we design PEP 740 is that the identity approach is currently very tightly tied to trusted publishing, which we did because it's a usability win. But there are other things that PyPI can conceptually bind with, such as verified account emails, because PyPI verifies emails on its accounts. Domain names, if a user attests to a domain name via some sort of like DNS or ACME verification. Or even possibly self-held signing keys, or keys that are tested via github.com/user/ I think it's .ssh keys, or whatever the public key discovery mechanism is for GitHub. These are all things that we're sort of abstractly thinking about, but this is an open design space where we could use feedback. And then finally, another sort of big elephant, something that I think about a lot is, even after all of this, we haven't fundamentally eliminated index trust. We're gonna make it harder for the index via like a tofu scheme to lie about the identity of a package that has provenance. But at the end of the day, the index could always strip away provenance with every upload, or the index could lie from the very beginning, et cetera. And there's a long-term goal, which is you should be able to use PyPI without worrying that PyPI one day itself will become compromised and either rewrite or maliciously sign for a package. Like I said, one of the ways that I currently think about this is this sort of tofu scheme, trust on first use, where a user, this is similar to what Go does, for example. You have a lock file, and the lock file has hashes in it, and those hashes are checked into a transparency database. Or in our case, the provenance identities are checked into the lock file, and you would check on every install whether the identities change. So you would see, for example, you do pip install, and you get the identity for the request package, and then one day you run pip upgrade, and request changes from GitHub/whatever/requests to GitHub/geotan/requests, and you think, that's weird, geotan shouldn't publish for requests. And hopefully you audit that and look into it rather than blindly trusting that identity change. But then even more broadly than that, because we have this huge tail of packages that can't be forced to use trusted publishing, these are people who haven't uploaded a package in a decade, we want to cover those people too, because they are a significant tail of all installs. And for those people, we're thinking about designs like index-wide binary transparency, similar to what Go has done, where you have not just individual publisher-side attestations, but you have this index-wide proof of consistency for every installation, where you have an immutable mapping of a distribution name and its hash that anybody who monitors the transparency log can verify. And with that, I wanted to leave a call to action. So this is all pretty new. Like I said, a core operational part of this was merged less than 48 hours ago. So we need your help. This is something that is a pretty active design space. If you're someone who does supply chain stuff for your company or on your own, we would love it if you consumed PyPI's PEP 740 endpoints. That's the raw endpoint there, where if you go to project version file name / provenance, you'll get the JSON. However, if you go to the index now, you go to the PEP 503 or 691 index, and it has a data provenance attribute. You can then pull this URL from that index instead. Please poke around, try and verify these. Let us know what usability errors you hit. Let us know if the documentation isn't fully merged yet. Let us know if there's the confusion you have around what we're offering. Alternatively, if you publish Python packages, if you aren't already using trusted publishing, please go ahead and enable it now. The good news is that you don't have to enable attestations because we'll do it for you pretty soon. However, if you also want to enable them explicitly, you can, and you'll opt into this slightly earlier than we will for the entire Python ecosystem. And then finally, if you're a Python developer, someone who just consumes or builds Python distributions for your office or your work, similar to that first sort of supply chain demographic, try verifying the things that we serve. The good news is that because if you have an external or third-party build system that isn't just PEP itself, you can add verification to your system. You're not blocked by the operational constraints that the Python ecosystem has. You can jump way ahead of the curve of everybody else and try verifying them directly. And if you do, please let us know, because we want to make this as easy as possible to use. And with that, that's my talk. The slides will be available online, and then I posted some initial resources. Like I said, the final docs for PEP 740 have not been fully merged yet, but that's the PEP itself, so you can read that to see how we designed it. And you can find me there online. Thank you.